Once more, have you any time considered what our sun looked like when it was an especially energetic star? The James Webb Space Telescope has made an amazing disclosure about our star. For whenever we first can see our star in an altogether unique light, the JWST's most ongoing divulgence offers spellbinding experiences into the youthful times of stars and the huge cycles that could have happened in the beginning phases of our star. Have we now opened one more of the great secrets of the universe because of the new James Webb Telescope? What secrets still look for us out there in the universe? The James Webb Space Telescope is a perfect portrayal of the changes made by frontline technologies. Since the telescope was sent off, the examination of the universe has progressed at a fast speed. With its latest mission, the JWST has exhibited its noteworthy capacity to dig deep into the insider facts of the universe. Indeed, the telescope displayed its absolute technical predominance when it imaged the object HH21 with great wonder. HH21 is also called a Herbig-Haro object, a very youthful star yet advanced enough that it's blowing solid planes into the universe and starting to shape its environmental elements. Since its concentrate by the JWST, the object has provided a wealth of significant information about the energetic period of stars and, subsequently, the beginning phases of our own sun. These perceptions furnish us with vital data about the processes that happen during the underlying stages of heavenly development. Herbig-Haro objects are among the most captivating astrophysical peculiarities in locales of youthful heavenly advancement. They comprise of restricted planes of gas shot out from recently framed stars, streaming into the encompassing interstellar space at high paces. These planes slam into encompassing gas and residue, resulting in emotional outflows. Herbig-Haro objects were found during the 1950s by cosmologists George Herbig and Guillermo Haro, who were independently examining star-forming districts and initially noticed the significant surges. Well before the JWST period, the energy-rich planes from the focal point of a youthful star are amazing. Who might have thought things would be so rough in the heavenly nursery? Youthful stars are everything but cuddly. They are for sure gorgeous but also amazingly strong. We can scarcely envision the powers at play here with our minds alone. The forces that lead to the development of a star are huge, and even in the underlying billion years, things heat up around a youthful star. It takes innumerable years for a star to ultimately sparkle as serenely and consistently as our sun. The object of the most recent perceptions, the Herbig-Haro object HH21, is arranged in a functioning star-forming locale in the heavenly body Perseus, around 1,000 light-years from Earth. HH21 is especially fascinating as it is one of the most youthful and nearest instances of these objects, making it an optimal field of study to examine the material science of star formation. The disclosure likewise gives us sublime perspectives on the dynamic processes that probably happened in the beginning phases of our sun's life. The JWST has imaged the Herbig-Haro object HH21 with exceptional precision, offering even additional captivating insights into what was once difficult to see. For the first time, it could even be feasible to see a double star forming at the focal point of HH21. The pictures reveal two splendid, high-energy planes radiating from a central object. These planes are enhanced with particles like carbon monoxide and silicon monoxide, and are proof of high-energy processes inside the star and its quick climate. The revelation of molecular hydrogen within the planes was a significant shock and now provides a totally new picture of the substance structure and thermodynamic conditions in the beginning phases of star advancement. The encompassing gradual addition plate of the youthful star and other objects, for example, planets and moons, could likewise form. However, the intensity of the energy expelled by the planes could make the arrangement of stable bodies more challenging. In any case, the JWST concentrates also showed that the planes of HH21 are slower than those of numerous other Herbig-Haro objects. This slower speed could demonstrate that the star is at a beginning phase of advancement, or that the cycles in this youthful framework are generally less wild than in other heavenly nurseries. The capacity to notice such key cycles up close and with high exactness addresses a significant headway in cosmology and will lead to increasingly interesting disclosures in the future. Noticing the birth of new stars likewise gives experiences into how ionized gases and plasma cooperate. The fiery planes that influence the cold encompassing interstellar medium create brilliant shock fronts that act as visual limits for the youthful star frameworks. These early outpourings of a star are much the same as the defensive shell of our sun's heliosphere. On a logical mission with the JWST, research teams are amped up for the extra prospects. The JWST is outfitted with a scope of inventive logical instruments, including the Near-Infrared Camera (NIR-CAM), the Near-Infrared Spectrograph (NIR-SPEC), the Mid-Infrared Instrument (MIRI), and the Fine Guidance Sensor (FGS). These instruments can distinguish even the slightest light from incredibly youthful and far-off objects that would otherwise be undetectable to our eyes. By utilizing infrared advancements, stargazers can now see through dust mists to reveal recently hidden corners of the universe and gain direct bits of knowledge into youthful stars and their arrangement districts, frequently clouded in thick residue shells. On account of the high awareness of the JWST, cosmologists and space fans can partake in a degree of detail that has up until recently never been accomplished in the history of cosmology. The JWST can not just picture these weak light signals, but likewise examine them. Never before have researchers had the option to see so much detail of the huge planes and exact studies, providing data on the advancement and temperatures of the gases, as well as subtleties of all the compound components and atoms included. Herbig-Haro objects, typical of dynamic star-forming locales like the Orion Cloud or the star grouping Perseus, are important for concentrating on synthetic cycles in space. These districts are wealthy in gas and residue, offering ideal circumstances for star formation. Stars are shaped from the aggregation of these assortments of matter influenced by monstrous powers. The jets catapulted by youthful stars, which travel through space at speeds of a few hundred km/s, are simply a part of the dynamic processes that happen during star improvement. When these planes influence the encompassing medium, they heat it up and make the trademark splendid bends and groups noticeable through our telescopes. Inside this striking presentation, tremendous actual powers are working as well as a light demonstration of the components, alongside electrical and attractive powers. Dazzling perceptions uncover how the planes interact with the encompassing material, assisting with molding the cloud from which the star is framed. Each light emission and each variety gives the JWST and thus the researchers important pieces of information about what's going on here. Noticing these cycles live and in their beginning phases is like getting a direct look into the outline of a star. Assuming we comprehend how matter is incorporated into the astronomical circle and how the last mass of a star is determined, we can make huge determinations about the powers at work. This, thus, assists us with figuring out the general matter development processes in the universe. Despite the fact that we can envision that star arrangement is one of the extraordinary energy processes known to mankind, it is hard to get a handle on that such a youthful star would be able to produce winds broadening a few hundred light-years and blow them into space. The planes of the Herbig-Haro objects could be immediate leftovers of the gigantic rakish energy that causes dust plates to start to turn and coalesce in the middle. Regardless, it is conceivable that the youthful star utilizes the planes to remove the forces it never again needs while simultaneously driving formative processes in the gas and residue cloud and star frameworks. Up until this point, we have only noticed jets in youthful and actively shaping stars. However, we additionally know about extremely old cosmic systems in the universe that additionally produce strong planes in their dynamic focuses. A portion of these vast twists stretch out a long way past their systems. These breezes probably additionally scatter gigantic measures of material, which ultimately impacts the mass of the star and the natural states of the star-forming area. The material and energy ousted then drive further star births or different components in the universe. We should consider briefly the job of attractive fields around a youthful star. Attractive fields are essential for controlling the growth cycle in which the star draws in gas and residue from the encompassing disk, and they moreover impact the heading of the planes. Attractive fields are not just huge in the prompt area of youthful stars, but are also present throughout the universe. These imperceptible powers direct the ways of charged particles and impact the shape and improvement of whole star frameworks. In our own nearby planet group, the attractive powers mediated by the Sun's attractive field are fundamental for keeping up with the heliosphere, the air pocket that safeguards the whole nearby planet group from unsafe infinite beams from interstellar space. The actual Sun produces a complicated and variable attractive field that decides the order of our planetary group, impacts planetary airs, and controls space climate designs. Sunspots, sun-powered flares, and coronal mass discharges are indications of the sun's attractive action. As you would know, such occasions sometimes fundamentally influence the activity of satellites and correspondence frameworks on Earth and produce auroras. The investigation of attractive fields and youthful heavenly frameworks like HH21 is an astonishing field of examination and is still in its beginning phases. If we comprehend the advancement of stars in far-off districts, we can likewise gain bits of knowledge into the historical backdrop of our Sun. Our star is 4.5 billion years of age and has gone through many changes since its introduction to the world in a dust storm and gas. The starting points of the solar system were determined, showing how planets were framed from the strong Jupiter to the rough planets, including our Earth, as well as different planets and moons. Furthermore, whether the JWST has the ability to capture those moments is at the core of the fascination in the perceptions. The JWST's mission is to give us some insight into the progression of time and how space, time, and matter were intertwined in the early universe. By observing young stars, we gain insight into their place in the universe, while a broader understanding of how planets form and evolve can allow us to predict the next stages in the history of life on Earth.